Okay, so I want to make a short video about implicit differentiation, and to make it a little bit more interesting, let's do something geometric. So I have an ellipse here, and the blue ellipse is described by that equation, x squared plus x times y plus y squared equals 3. And the red point that you can hopefully see is the point 1, 1, 1. So what we're going to do is use implicit differentiation to find the equation for the line tangent to the ellipse at the red point. Right. So if you can read this text, so on the first line just shows the equation again. And so here you can see the thing that we want to find y prime for. So the first thing you do is you take the derivative with respect to x of both sides. So let's just see what happens here piece by piece. So x squared becomes 2x. X times y, you have to use the product rule. So this y here is just the product rule, the derivative of x is 1. And now the second part of the product rule, x stays the same, and you take the derivative of y with respect to x, which is y prime. And now for this last part, the 2 comes down, and y prime pops out by the chain rule, and the derivative of 3 is 0. So now you just have to do some algebra. So you can see these two parts have a y prime in common, so you can factor them out to the right here. And now move these things over to the right hand side of the equality and divide both sides by x plus 2y, and that's how you get this expression for y prime. So now that we have this expression for y prime, we're ready to start to find the equation for the line tangent to the ellipse at the red point. So the first thing we need to do is find the slope of the tangent line there. So that's just the derivative evaluated at the point 1, 1. And when you plug 1, 1 into this expression, you can see that you get minus 1. So that means that the slope of the tangent line through the red point is going to be minus 1. And once we know that, we're ready to use point slope form. And so we know m is minus 1, and we have a point that's given to us. So the equation for the line that goes through the point with the slope is given by this formula. x1 is 1, and y1 is 1, and m is minus 1. And when you collect everything together, you just get y is equal to minus x plus 2. And if we plot that line in green on the same frame as the blue ellipse, you can see that it was a success, and the green line really is the tangent line to the ellipse. So I know sometimes people get confused about why the y primes pop out, and since I think because some people don't understand why the y primes pop out, they just don't, I don't know, they don't produce any y primes when they take the derivative of y expressions. So you have to do that, and this is the reason why. So when we were doing the derivation in the first part, y squared, when we took the derivative, became 2y times y prime. But x squared just became 2x, so it doesn't really seem fair. So why does y have to spit out a y prime, and x doesn't have to spit out anything? And the reason is because we were taking dx of both sides. So this means the derivative with respect to x, and so that's the difference. This dx makes x special, so x is the variable. That means its derivative is just 1. But if you have a function of y, like f of y, so in your head you should be thinking y squared or something, and you take its derivative with respect to x, then the chain rule says that in this situation the derivative of the composition is the derivative of the outside function with the original inside times the derivative of the inside. And what that means in a particular situation like y squared is when you take the derivative of y squared with respect to x, you can just take the derivative of the outside function, which is the square function, the 2 comes down, but then by the chain rule you have to multiply by y prime because y was not the variable. Okay, so let's do one more implicit differentiation problem, and in this problem we want to find the second derivative of the square root of x plus the square root of y equals 1. And okay, so you start with the equation, and then just like last time, just like always, you apply d dx to both sides. So you know that x, the square root of x is really x to the 1/2. The square root of y is really y to the 1/2. So those 1/2s come down. You take one away, and it makes minus 1/2. And in the case of y, the y prime pops out for the reasons that we were just talking about, and the derivative of 1 is 0. Alright, so now you have to collect the y primes, so I kind of skipped through that part a little bit. But you just move this over to the other side of the equality, which makes it negative, and then you divide both sides by y to the minus 1/2, and the 1/2s kill each other, and so you get this expression, and this simplifies to this. If you want to prove when that's true, you can sort of factor the minus 1/2 power out of both pieces here, and then get rid of the negative by taking the reciprocal and then put it back, and so that's where this expression comes from. So now that you have this, you want to find y double prime, and this is even a little bit easier than finding y prime. So just apply d dx to both sides again, and on the left you get y double prime. That's just what y double prime is. And on the right you use the quotient rule. So this first part is the derivative, the minus sign just hangs out. The first part is the derivative of the square root of y again, and times original bottom, which is square root of x, now minus, and you take the derivative of the bottom, which is this, leave the top alone, and this is the bottom squared. And that's the end of the problem.